So in this video, we're going to talk about symmetry in the polar equation form. So symmetry with respect to the polar axis, okay, the x-axis. So in a polar equation, we replace theta with negative theta. If an equivalent equation results, then the graph is symmetric with respect to the polar axis, meaning f of theta equals f of negative theta. Okay. The next one, symmetry. So what is that? I guess what does that look like in a picture? So like say you've got your polar axis. Okay, you've got some point up here, and this is r theta. That same point is down here at r negative theta. Okay. Symmetry with respect to the line theta equals pi over 2. This is y-axis symmetry. So how does this work? In a polar equation, replace theta with pi minus theta. If an equivalent equation results and the graph is symmetric with respect to the line y-axis, which is theta equal pi over 2. So f of theta equals f of pi minus theta there. So what does this look like in the picture? Got your polar axis. If you've got the point here, r comma theta. So that's some angle theta. Now, you got your y-axis here. Y-axis symmetry would be over here. Now, to get over to this point, well, if I go all the way over, I get to pi, right? But I want to subtract away this theta here. So that angle from here to here is pi minus theta. So this is r comma pi minus theta here. Okay? And then the other one, the last one, symmetry with respect to the pole. That's origin symmetry in Cartesian, rectangular form. So in polar equation, replace theta with pi minus theta and replace r with negative r. Okay? So what does that look like in a picture? So if I've got this point right here, r theta, over here, okay, how do I get over there? I add pi. Oh, I need to replace with theta plus pi, not minus. So plus pi, I add pi to get over here. And then I do the negative of it. So this point over here is r comma pi plus theta. Okay, which is equal to negative r comma theta. Okay. So it's symmetric about that pole right there. Now the three tests for symmetry given here are sufficient conditions for symmetry, but they are not necessary conditions. That is, an equation may fail these tests and still have a graph that is symmetric with respect to the polar axis and the line, theta equal to pi over 2 or the pole. Okay, so for example, the graph of r equals sine 2 theta turns out to be symmetric with respect to the polar axis. The line, so it's symmetric with respect to polar axis. Theta equal pi over 2. So polar axis is x-axis, y-axis. But not only the test for but only for the test of symmetry with respect to the poles does it work. Okay? By replacing theta with theta plus pi. All right. So this next part here, we're going to be graphing.